Welcome to True Projects. In this video, we are going to explain about the project title Machine Learning Approach for Predicting End Price of Online Auction. Before diving into the execution, let me give you an overview of the project. Let us first understand what online auction is. Online auction is a type of auction conducted over the internet. In the online auction, we have sellers and buyers. The sellers will sell the product with a starting price and the buyers will bid for the product to buy. With each bid, the price will increase. The sellers will provide us with the basic information about the product which they are selling, and the buyers will bid for the product which they need. Online auction is having many benefits. One of the benefit of online auction is accessibility. It is accessible to a global audience. That is, anybody from any location can participate in the online auction. And it is convenient to participate in the online auction because we can participate it from anywhere. That is, we can participate it from the home, office, or even from a cafe with a good internet access. So online auction is widely accessible and convenient to participate. In this project, we aim to predict the end price of online auction using machine learning algorithms. Traditional methods for predicting online auction involve manual analysis, statistical techniques, expert advice, and trial and error strategies. But these traditional methods had some limitations, which were subjectivity, inefficiency, and inability to handle large data sets, inability to adapt to changing market conditions. To overcome these limitations, in the base paper, the author proposed various machine learning algorithms for end price prediction in online auctions. For range index, classifiers such as support vector machine, navy Bayes, k nearest neighbor, decision trees, and random forest are utilized. And for closing price, regression algorithms like SVR, support vector regressor, Bayesian regression, k nearest neighbor regressor, decision tree regressor, and random forest regressor are utilized. The system's objective is to develop accurate predictive model through data processing, training, and evaluation to improve auction price estimation in online platforms. To further enhance the performance for predicting end price in online auction, we have proposed voting classifier for range index and voting regressor for end price prediction. These ensemble techniques aim to produce more robust and accurate prediction within the online auction context. The project predicts closing prices in online auctions based on various parameters and classifies them as low or high, providing valuable insights for participants. In this project, we assess algorithm performance for predicting closing price in online auction using evaluation metrics like accuracy, precision, recall, and F-win score. These metrics show how well algorithms predict and differentiate between low and high closing price. The proposed system benefits both sellers and buyers in online auctions by providing accurate predictions of end prices for auction items. Sellers can optimize pricing strategies and gain a competitive edge, while buyers can make informed decisions, mitigate risk, and save time and effort. With data-driven insights and automated predictions, the system empowers users to enhance their auction experience and maximize profits effectively. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used in this project. In the base paper, the author has utilized these algorithms for range index, and we have proposed voting classifier for range index. Voting classifier is an ensemble learning technique that combines predictions from multiple individual classifiers, specifically random forest and decision tree, to improve classification accuracy. Random forest constructs multiple decision trees during training and outputs the mode of their predictions, while decision tree partitions the data based on feature values to make predictions. By aggregating predictions from these diverse classifiers, the voting classifier enhances prediction performance by reducing overfitting and bias, making it robust for classification tasks. And these are the algorithms built in the base paper for closing price prediction. But to further enhance the performance, we have proposed voting regressor. Voting regressor is an ensemble learning method that combines predictions from multiple individual regression models, including random forest regressor and decision tree regressor, to enhance accuracy in regression tasks. Random forest regressor constructs multiple decision trees during training and averages the predictions to reduce overfitting, while decision tree regressor predicts continuous value by partitioning the data based on feature values. By aggregating predictions from these diverse regression models, the voting regressor improves prediction accuracy and robustness in predicting continuous variables, making it effective for regression problems. Now, let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the dataset folder. So in this data set, these are the features which we have. The first one is auction ID, bid, bid time, bidder, bidder rate, open bid, price, item, and auction type. So this auction data set will be pre-processed, that is removing null values, convert categorical variables into numerical representations. And after pre-processing this data set, this is the data set after pre-processing, in which we have these features. The first one is auction ID, bid value, bid time, bidder ID, bidder rate, open price, closing price, item ID, and auction type. And this data set will be further processed. And after processing this data set, this is the data set which we get, in which these are the features which we have: auction ID, item ID, auction type, bid value, bid time, bidder rate, open price, closing price, rank, numbers of bid, previous bid value average. And here, this is the target variable, that is the closing price. And this data set will be divided into train and test. Train set is used to train the algorithms, while the test set is used to evaluate the performance. This is the sample data set. in which we have auction type, bid value, bid time, bidder rate, open price, rank, number of bids, previous bid value, previous bid value average. And here we have the label, that is the closing, whether the closing price is low or high. So by using these features, we will predict the closing price as either high or low. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered, so click on sign in. So here we need to enter the username and the password, which are static, and then click on sign in. We have signed in successfully and we are redirected to the prediction page. So here we need to enter the values of these parameters. Before entering the values, let us understand the meaning of the parameters. The first one is auction type. This refers to the type of auction being conducted, such as standard auction, reserve price auction, buy it now auction, etc. Bid value, the amount of money a bidder offers for an item in an auction. Bid time, the timestamp indicating when a bid was placed during the auction. Bidder rate, the rating or reputation of the bidder, often based on their past activity or feedback received from other users. Open price, the initial price set by the seller to start the bidding process. Rank, the position or level of importance assigned to an item or bidder within the auction. Number bids, the total count of bids placed on an item throughout the auction duration. Previous bid value, the value of the previous bid placed before the current bid. Previous bid value average, the average value of all previous bids placed on the item before the current bid. Now let us enter the value. After entering the value, we will predict the closing price as either high or low. So here the auction type is 2. Bid value is 80. Bid time is 0.961. Bidder rate is 0.52. Open price is 24.5. Rank is 5. Number bids is 9. Previous bid value is 63. Previous bid value average is 42.37. Now click on predict button. So here we can see the result, that is the closing price is 148.824 and it is low. So here we can see that the closing price is low. Now let us enter another set of parameters and check the closing price. Click on home. So here I'm entering another set of parameters. Auction is 2. Auction type is 2. Bid value is 201. Bid time is 0.522. Bidder rate is 0.6. Open price is 5. Rank is 8. Number of bids is 13. Previous bid value is 200. Previous bid value average is 107.217. Now click on predict button. So here we can see the result, that is the closing price is 235.433 and it is high. So we can see that the closing price is high. Now let us enter another set of parameters. Auction type is 1. Bid value is 100. Bid time is 0.681. Bidder rate is 0.181. Open price is 62. Rank is 3. Number of bids is 6. Previous bid value is 92. Previous bid value average is 68.275. Now click on predict button. So here we can see the result. The closing price is 208.468 and it is low. So if the closing price is greater than equal to 250, then it will be high. And if it is less than 250, then it will be low. So here we can see that it is less than 250. That is the reason the closing price is low. Now let us enter another set of parameters. Click on home. So here the auction type is 1. Bid value is 251. Bid time is 0.63. Bidder rate is 0.16. Open price is 215. Rank is 4. Number of bids is also 4. Previous bid value is 248. And previous bid value average is 225. Now click on predict button. So here we can see the result. The closing price is 237.473 and it is high. In this way, by entering the parameters, we can predict the closing price has either high or low. Now click on graph link. So here, this is the correlation matrix, which tells us how the variables are correlated. And here we have the comparison graphs for the evaluation metrics accuracy, precision, recall, FN score, So here on the x-axis, we have the values, and on the y-axis, we have the algorithm name for each valuation matrix. So the algorithm which is performing best will be deployed in the front end to predict the closing price. So here in this project, voting classifier is performing well and it is deployed in the front end. And here we have the R2 score. On the x-axis, we have the algorithm name, and on the y-axis, we have the R2 scores value. So here we can see that the voting classifier is performing well compared to the other algorithms. Now click on sign out link. In this way, by entering the parameters value, we can predict the closing price in the online auction.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.